Hey there, AP Pre-Calc kids. Here I am, doing work. Surprise, I'm not here. Just to bookmark this, I have COVID. So, we'll see when I'm back. So, let's take a look at example 11, though. You can't stop me. A buoy oscillates as waves go past, so it goes up and down with the waves. For any given time, it moves a total 4.5 feet from the lowest point to the highest point. So that means that total height is going to be 4.5. I don't know how I'm writing it. It goes from a high point to another high point in 15 seconds. All right, so let's make an equation that models this. Okay? So, what are some things I know? What's my amplitude? Well, it's 4.5 total height. So I need to cut that in half to get amplitude. So that's 2.25. Now if I was really cool, I could have done this as a fraction as 9/4. Both are fine. Just remember, probably non-calculator. And that's a smudge. It's 2.25, not 2.2.5s. I don't know. Who knows? I don't feel good. What else do we need? What's my b? Remember, 2 pi over b equals my period. This time my period was 15, right? So some quick solving tells me, remember, that's how you can solve a ratio, that 2 pi over 15 equals b. What else do I know? I start at a high point. I start at max. So am I going to use cosine or sine? From its low point. Ooh, never mind. It's at its lowest point at t0. So we're starting at a low point. Usually cosine starts at max, but this one's starting at min. So I know this is going to have to be negative in front. So I do my equation is going to be negative 9 over 4, my amplitude, cosine of 2 pi over 15 x or t. I'll use t because we're doing time. It's going to be my equation, my d, my distance. Okay? All right. That's not too scary. Fan turned off. All right. Let's keep trucking. What is the frequency of the motion explained in context? Well, we know frequency. If my period is 15, that means it's 1 over 15. And remember, that's 15 seconds. That means it's 15 seconds for one cycle. That's how long it is. So this would be one cycle every 15 seconds. So that means I have 1/15 of a cycle per second. A 15th of it passes. So in context, the buoy moves 1/15 of the path per second. Okay? More explaining. Eep. Alright. I kind of need to save this. We'll figure it out. Alright. Using the graphing utility, use a graphing utility to find the point of inflection where the buoy is at equilibrium. How would you do that? Alright, so by graphing utility, it means use a calculator, right? So how would I do that? So if I grab said above, the function from above, it's going to look like this, right? Where this is my y equals 0 is going to be my midline based on my equation because there's no shift. So point of inflection is going to happen when this graph passes 0. So if I'm using my TI-89, I could graph it and graph the line y equals 0. Don't even have to. Do I have my Wabbit? I'll show you with my Wabbit. Let's see if that opens. But anyway, I could graph it, find out when that equals 0. Okay. If you do that, that point is 3.75. Now what I also could have done, oh, that's just great. Get out of here. That's not my Wabbit. All right, maybe I'll just have to show you guys later. So I'm looking for when it goes from concave up to concave down. So you go from going up to going down, increasing degree. It's a rate changing. So what's half of 15? Half of 15 is 7.5. And if I cut that in half again, I get 3.75. Right? I should have done this because this was 15. So half of that is 7.5. Cut in half again, I get 3.75. So at t equals 3.75, t equals 3.75. I'm going to cheat. Till I was cheating. So when it's 3.75, the buoy's at equilibrium because you're going from concave up to concave down. Your points of equilibrium are going to be when you're crossing that midline because you're changing your rate change. You may have to pause it and write it. Please and thank you. All right. Oh, never mind. Here it is. What does equilibrium mean in terms of behavior to the wave? It means that's the midline of the height of the waves. Okay, it's kind of like a roller coaster. It's when your rate of change goes from decreasing to increasing. Again, pause it, write this down. When is it decreasing? That's a good question. Well, when we looked at our graph, one period is 15, right? So, it doesn't tell us where, but we'll figure it out. So we're decreasing. We started at that negative, right? We started at bottom. We went up. So you could have said it's increasing from, it just wants decreasing. But we're increasing from 0 to 7.5 seconds. And then we decrease from 7.5 to 15 seconds. And that's going to happen every 15 seconds after. Plus 15n, where n is an integer because 15 is our period. Okay? There we go. That's a free response question. Hope you enjoyed. You can do all 3.5 now. Work on it in class. Tomorrow will be a work day and video day. All right. Have a good one.